Hello, and today we're going to be talking about inequalities and graphing inequalities. So, an inequality is something like 5 is less than 7. 5 is less than 7, it is called an inequality. So, these inequality symbols are the less than, the greater than, the less than or equal to, the greater than or equal to signs, and also the equal to sign. So all these symbols here are inequalities. Now we know what the equal signs is, so we're not going to worry about that. We're going to worry about these here. So the way that we're going to do that is by sketching the inequalities on a graph. So if I said x is greater than or equal to 0, that means that there's going to be a line right where x is equal to 0. So along this line here, might as well make it a different color. Right, this line here, and if we were to graph this, well, this line is where x is equal to 0. So where is it not equal to 0, but it still solves the inequality? So x has to be greater than 0. So is 1 greater than 0? Yes. So everything where the 1 is, that's all fine. Well, everything less than 1 that's not 0, that also works. What about things greater than 1? Yes, that all works. So as long as the area is greater than 0, it'll fill the inequality, as I am demonstrating here. So everything that's green solves the inequality, and imagine that this white gap didn't actually exist. But what this is called the region required. And when we do graph an inequality, we actually have to put a key. We have to say, well, what is the region required? Well, the region required is the highlighted area. Well, that could be the white space over here, or it could be the green highlighted space here. So in this case, it's the green highlighted space. So I'm going to put my key over here, and I'm going to write RR for short, region required. And then I have to color in the box so it works with my key. I have to color in the box so it works with the graph that I've made here. So what this is saying is that my region required is everything that's green. So everything that's green, all of this area here, that's my region required. That's everything that I need. Right here, all here. So let's talk about I just don't want to lose my lines. Okay. Well, we looked at x. What about y? Can y work? Well, yes, y can work. So let's say y is smaller than 5. So we just work out where 5 is. Let's say 5 is here. That's 5. And then we rule a line where y is equal to 5. So here. But notice that we're not having y is smaller than or equal to 5. This is y is smaller than 5. So what that means is that we have to make a broken line or a dashed line like this. And this broken slash dashed line represents where 5 is, but we're saying that y never actually equals 5. It gets really close, but it's not actually 5. Again, we have to put our key in, our region required, our RR, and then we have to fill in what the region required actually is. So I'm going to say that the region required is everything here in green. And it's the same thing. Everything that's less than 5 on the y-axis is here in this green area. And that's how you solve for this inequality. So, what if I don't want y is greater than or equal to 5 or something like that? What if I want a line instead? Well, we can do that as well. So get rid of all these things. Grab up the rest. What if we had a line x plus y and it was greater than or equal to, let's say, 2? Well, what does that mean? Well, we have our line where 2 is, so let's say 2's here and 2's here, and we would graph this line like we normally would. It's not exactly a perfect this is not the scale. So we sketch the line like we normally would, and then we have to work out, well, what's our region required? Well, that's right, RR, and then let's define it as the highlighted area. And well, what is this highlighted area? Well, we can check it, so we write check, and then we have to write some sort of, we have to say check for a certain point. So a good point to check is a point that's not on the line, but it's easy to work out if you have something like an x squared or 2x, etc. So a really good example is 0, 0, because that way you'll get rid of x and y. So in this case, we'll check 0, 0. So 0 plus 0, is that smaller than or equal to 2? Well, it's smaller than 2, so yes, that point is in the region required. So that means everything below the line here is part of our region required. And we can also so there's our region required for this particular inequality. We checked for 0, 0. We found out that yes, that 0, 0 is in the origin. It is 0, 0 is part of region required. But what if we found out that 0 wasn't part of region required? What if we had this line? Instead of smaller than or equal to 2, it is greater than or equal to 2. Well, the line doesn't change, What changes is the region required. So I'm going to move this here. And we'll do our check again. So check 0, 0. 0 plus 0 is not greater than or equal to 2. So 0, 0 is not part of our region required. So we will highlight everything above the line. Like so. What if we had something that was on the origin, for example, and we wanted to work out an inequality? Well, we don't have to check for the origin. We can check for another point, like 1, 1, or some other point that's not on this line here. So that's all I have time for today for this, for graphing inequalities. If you have any questions, feel free to ask in the comment section below or on social media, and I will see you in the next video.